Alright, my name is Jay and from Lab Group 4, and this is problem 19 of EM waves. So unpolarized light of intensity I naught is equal to 750 watts per meter squared. It is incident upon three polarizers. The axis of the first polarizer is vertical. The axis of the second polarizer is rotated at an angle of 75 degrees from the vertical, and the axis of the third polarizer is horizontal. So for part A, it's asking what is the intensity of the light in watts per meters after it passes through the first polarizer. So now, because there's no angle, the equation we use is the one given in the textbook, which is the intensity passed from the first polarizer without an angle is the half of the initial incident intensity. And since my incident intensity was 750, my new one would be 375. For part B, what is the intensity of the light after it passes through the second polarizer? So for here, since it passes through a polarizer with an angle, so we use this equation, the I2 is equal to I1 cosine squared of theta. So 375, and my angle given was 75 degrees. So that answer is 25.12 watts per meter squared. For part C, what is the intensity in watts per meter squared of the light after it passes through the third polarizer? So now, since the third polarizer was horizontal, we need to find the other angle, because if you draw out a 30 of a triangle, then using the triangle rules, it's the opposite angle that it gets reflected through. So then what I did was I just subtracted 90 from 75 and I got 15. So then I used the same equation from before, and then I multiplied them together except with 15, and I got 23.42 watts per meter squared. You can use the sine of 75, but I prefer to use cosine just to keep it consistent. For part 4, it says part D, write an equation for the intensity of light after it has passed through all three polarizers in terms of the intensity of unpolarized light entering the first polarizer and the angle of the second polarizer relative to the first, given that the first and third polarizer are crossed. Between them, use trigonometric identities to simplify and give the results in terms of a single trigonometric function of phi to theta. So for this, since we're using all three, we know that our final incident angle is I3. So our first incident light, it goes through the first polarizer, it goes through without an angle. So that means this is there. And that angle, whatever that light is then multiplied, because it goes through a angle of 75 degrees through the second polarizer. So we just multiply it with cosine squared theta. And then it passes through another set with third. It passes through a third polarizer on the horizontal, so we use the opposite angle. But in this case, we can actually use sine instead. So we just multiply that, and then that's our final. After it crosses the third polarizer, the intensity of the third light can be found. So using a little, trigonometric identity, sine theta plus times cosine theta is just sine 2 theta. So then your new value is I3, and then I squared the top, I squared the bottom, brought the 4 out, multiplied it by the 2. So then you have I3 equals I naught over 8 minus sine squared of 2 theta, or phi in this case. And then for part E, it's asking what is the smallest angle in degrees from the vertical that the second polarizer could be rotated such that the intensity of light passing through all three polarizers is 68 watts per meter squared. So in this case, we just use the equation that we derived in part D. So we use the original, since it's asking for angle 2, it's talking about, we're using the intensity that was given to us, which was 750. So then I plugged that in, 750 over 8 times sine squared of 2 theta is equal to 68. And then I solve for theta, so then that means that theta 2 is equal to 29.2 degrees. And that is the smallest angle from the vertical that the second polarizer can be rotated.